the ultra-high performance concrete for prefabricated bridge element connections. So as part of any accelerated bridge construction or prefabricated bridge element workshop that I've done in the past for you, we have a tradition. You pull out your right hand. You turn to that complete stranger to the right or to the left or to the front or to the back of you, and you introduce yourself. So with that, let's go ahead with some brief introductions. You can stand up. It's just like church, guys. Welcome. How you doing? We'll never get started, huh? We need this. Okay, you guys ready? All right, does everyone have those two sheets that I passed around? Don't fill them out just yet, all right? We're going to kind of do it as we go through this PowerPoint presentation. So you'll see in there, I'm going to give you a little brief introduction and overview of this, the topic I'm going to talk about. Of course, it is the ultra-high performance for prefabricated bridge elements, what we'll call UHPC/PBE, the initiative purpose. We're going to talk about what is UHPC, provide some reasons to use it, really some examples, we'll show you some, and we really want to talk about the deployment activities in this initiative. This is really a non-technical presentation, okay? There are a couple technical things that I do want to talk about. It is important, but we're going to keep it light. We have to keep it light. You can't give a technical presentation after 3 o'clock. That's the rule. I didn't know if you guys were aware of that. And we'll reserve those types of technical presentations for things like workshops and other deployment activities as well. So, before we begin, if you do pull out that one sheet, it has questions on it. If you look under question number 1, before I say anything about ultra-high performance concrete, we'll go to question 1, and I want to ask you all this. Knowing what you know about UHPC, your business practices, your inventory, your agencies, or your industries, what we'll say receptiveness to adopting new innovations, how viable or how practical do you think UHPC for prefabricated bridge applications would be in your state? Just fill out the before. And I'm going to ask you the same question after I get done with this, and we'll see if it changes, okay? So just go ahead and take a minute with that. And if you want to, you can identify yourself, or if you choose to remain anonymous, that's fine. We're only the federal government. It's not like we're not going to find out anyway who you are. So anyway, try your best at that. Okay, so fair enough. Purpose of the Ultra-High Performance/PBE initiative. Well, it's a national deployment effort to address the industry's desire to improve upon the durability, the fabrication, and construction aspects of prefabricated structural elements using ultra-high performance concrete. It's pretty simple. Although long, it's very simple. So what is ultra-high performance concrete? Now you look at this slide and you say, well, geez, Ben, you can't even keep your icons straight. There's a check. Ultra-high performance is recognized as being a concrete with high compressive strength. That's pretty common. What's not common are those two items that you see that are kind of have those arrows right here. Ductility in the post-crack state, and I'm going to talk about that, and the ability to internally bridge cracks, and that's without the need of secondary reinforcement. And I'm going to talk about that. Those are the two technical things that I'm going to talk about. Ultra-high performance concrete is dimensionally compatible with the material that it resides in, usually concrete. It essentially has zero permeability. And when I talk about permeability, we'll talk about something that we all recognize, coulombs. High performance concrete, which is different from ultra high performance concrete. Typically what we spec in our decks. We've been pushing this initiative Oh gosh, for the past 10, 15 years now. High-performance concrete usually has Coulomb values of about 1,500. That's where we set that threshold. Typically, we see numbers around 1,000, maybe 800. Ultra-high-performance concrete, in terms of that Coulomb permeability type perspective, you're going to see some numbers like 300, less than 100. It's very common to see things like that. So it's essentially zero permeability. And it has excellent bonding capabilities. And that's if you prepare the joint correctly, if you design it correctly, things of that nature. So we're going to tackle these two unique material characteristics, and those are those two right here. Ductility in the post-crack state, and the ability to internally bridge cracks. Now it's important that we discuss these items. I am not going to go over compressive strength, dimensionally compatible, that's shrinkage, zero permeability, and bonding capabilities. I think we all can recognize that. But it's these two we do need to talk about in a little bit of detail. This is a picture of ultra-high performance concrete. This is actually a prefabricated deck panel right here and here, and here's the ultra-high performance concrete. Here's our grouts. I hope you can see this picture, but you see how the grout pulls away from the edges and how it sinks into its connection. And here's good old concrete. This is a hot mix. We put the cement in there to get that high early strength, and we typically see a nice thermal type crack occur. All right? So let's take this first one. Ductility in the post-crack state. I want to explain this concept to something that we're all familiar with. All right? We have structural engineers in here. Who's got a civil engineering degree? All right, great. So if you went to a decent school, you've seen things like this. I know your eyes are rolling, but it's something we're all familiar with. The old stress strain curve. We take a machine like this, we take a piece of steel and we throw it in here, and we pull on the steel. The steel exhibits stress and strain. Beyond the yield stress, when we pull it, it goes back to its shape. That's, well, when we're below the yield stress. When we go beyond the yield stress, we have this ability with steels to increase the stress as we increase deformations. That's what we call strain hardening. It's ductility, well, it's just strain hardening. We'll just leave that as is. You kind of say, well, Ben, why are you making me go through this? Because we're going to do the same thing to a piece of concrete. Usually we put concrete in compression. We're going to show you what happens when we put ultra-high performance concrete in tension. And we're going to compare that to conventional concrete, and we're also going to compare it to what we call strain softening concretes. And those are concretes that don't have the steel fibers in them. Those are concretes that have the polyvinyl alcohol type fibers. There's some samples of what is ultra-high performance concrete at the table there. I'd ask if you guys could go ahead and just pass that around. You'll see the steel fibers. You'll see that gray little puck right there. That's not something that you shoot. You can smell it. It does smell like chocolate, right? No, it doesn't. It doesn't smell like anything. I just wanted to see if you would open it. You can also open up those steel fibers as well. They'll prick you. Don't complain and don't scream. That's not manly enough. So, you know, just take your pains as it is. But all right, so let's go ahead and do this. All right, we're going to take a piece of ordinary concrete and we're going to put it in tension. It's going to go up a curve. It's going to crack. Okay? Pretty simple. What we're going to do is take what we call those strain softening concretes, the ones without the steel fibers. It's going to do the same thing. We're going to go up the curve, then it's going to stop, and then it's going to go down this way. This is what we call strain softening. Okay? So there's the concrete. There's concrete with the what we'll call polyvinyl fibers, and then we're going to show you what happens when we put ultra-high performance concrete in that machine. Now the tensile capacity of ultra-high performance is extremely high. It's about 4 times that of ordinary concrete. Okay? We're going to go ahead and stress that. You'll initiate what they call a first crack, and then as you continue to pull on it, it's going to develop what we call micro-cracking. It'll look something like this. All right? And as you continue to stress it, you'll find that you'll be able to, through increased deformations, you'll have the ability to carry increased stress. And that's what we call that ability, strain hardening, or that ductility in the post-crack state. It is a unique material characteristic that separates ultra-high performance concrete from other cementitious-based materials. Okay? No other cementitious-based materials has this property. Now, it's important not just to distinguish itself from other types of concrete materials, but if we go to codification of the material, we're going to use this characteristic. And we'll talk about codification in terms of objectives and things that we want to pursue or would like to pursue in this EDC initiative. Okay? So that's the first thing. Now there's going to be a test. Oh, whoop, hang on a second. We simplify the graph like this. All right? Now remember, ultra-high performance concrete is strain hardening concrete. The reason I say this is because there is going to be a test at the end of this presentation. There's only 2 questions. This is one of them. So say it with me together. Ultra-high is strain hardening concrete. Strain, it's hard. Oh, it's concrete. All right, it's hard to remember. It strains my brain, right? All right, let's talk about the second unique material characteristic. And this is ultra-high performance ability to bridge cracks without the need of secondary reinforcement. That temperature and shrinkage reinforcement that we put in concrete, those number 4 and 5 bars that we space like at 12 to 18 inches, you don't need that. But I want to also explain the same unique property from a corrosion cracking perspective. If we take concrete, ordinary concrete, and we crack it, sort of at this macro cell, you're going to get a larger crack than you would if you were to crack UHPC. And I emphasize, if you could crack it, especially in the applications that we're talking about for this particular initiative. It's if you could crack it, okay? You'll get much smaller cracks. You'll have these steel fibers that work with the tight matrix that composes of the ultra-high performance concrete. And the anode to cathode ratio that's set up is going to be a whole lot smaller. Smaller anode to cathode ratios results in less corrosion, okay? Anyway, but you can look at it from this perspective. You can look at it from this perspective. When we build elements with ultra-high performance concrete, it's not what the emphasis of this particular initiative is, but it could be if we continue on with this and build our market. You don't need to use those temperature and shrinkage cages. You can just go ahead and pour the ultra-high performance concrete and use regular post-tensioning, pre-stressing, or large reinforcement embedments into that element. So those are the 2 unique material property characteristics: strain hardening and the ability to bridge cracks. This is not on the test. This one is. The reason why this one is, if we come and do a workshop in your particular state, we go, oh, we're going to do one on ultra-high, and oh, that's that high compressive strength concrete around 20 to 30 KSI. No, I don't want to hear that. I want to hear we're going to do a workshop on strain hardening concrete, okay? So that's the technical stuff of this presentation right there. You can find more information. We have Turner Fairbanks has printed this material property characteristics of ultra-high performance concrete. But what I really want to do is talk about why do we use ultra-high performance concrete? What are the benefits that we get if we are to use it? And I'll provide you some examples. Designers can take advantage of these material characteristics of ultra-high performance concrete, and they can change the way that they do the detailing. The detailing simplifies the fabrication, and the fabrication can simplify the construction. All of them are linked together. As designers, as us in the bridge community, if we bring in ultra-high performance concrete into our industry, it's going to challenge our existing practices. It's a game changer. It allows us to change things. The ultra-high performance matrix, it's tight. It's like the marble of concretes or the granite of concretes. And you can see that through that permeability. Okay? Those steel fibers, they work together with that tight matrix. It allows us to reduce the development lengths by a factor of 3. Here's an example. If you were just to do a regular development length of a straight piece of rebar in ordinary concrete, the rule of thumb is like 24 bar diameters. If you take that same piece of rebar, you put it in ultra-high performance concrete, and it has that ability to bond quicker, it'll take that development length and reduce it to like 8 bar diameters. Okay, so about like a factor of 3. And that does change a lot of things. And I want to show you some examples of that. So what we're going to do is start off with the ever so famous adjacent box beam bridge. How many people have this in their inventory? Can I get a raise of hands? Probably one of the most popular bridge types in our inventory from a national perspective. I'm sorry, you'd think a guy like me could have a better picture of this. This is what the top looks like. Sometimes this is what the bottom looks like. And if you get a closer look, this is what some of the joints look like. Okay, there we go. The computer and the screen don't quite match up. Anyway, you've all seen this before. For years, our industry has looked at those longitudinal joints and said, what is it that we can do to improve upon it? And this is since the 60s, before I was born. So we look at the joints and we say, okay, well, maybe it's the joint shape, maybe it's the joint size, maybe it's the joint material. Well, those are the first things that we've done. Okay, we went ahead and we put transverse post-tensioning in it. And when I say transverse post-tensioning, we're talking at 18 to 24-inch spacings, not the 10, 12, 15 feet that you typically see. All right. Other strategies, none of that has worked. You know, we still get the cracking, we still get the reflective cracking. Other strategies, folks use a membrane with asphalt. Some folks take that rebar cage in that box beam, they lift it up, and they'll put a single mat of reinforcement out there. They'll pull a crew out there to tie that re-steel. They'll pull another crew to come out there to go ahead and place that 4 to 5 inches, 4 to 6 inches of overtopping. And we'll make what we'll call the Sherman of all bridges. We can simplify this detail. We can provide a much more durable detail such that full moment and shear transfer across the joint does occur using ultra-high performance concrete. This is the joint detail here. The blue, I hope it's blue from where you're sitting at, is the ultra-high performance concrete. That's a typical number 4 lap splice. It's a non-contact lap splice that's placed in this 4 to 5 inch pocket. This is where you pour it, this is where it flows. No membrane with overlay, no composite deck, no joint linkage. Basically what you do in this strategy is you take your boxes, you overpour them about 2 inches, you come in, you install your ultra-high performance concrete, let it cure, you come in there and you profile it. Done. That's it. Leak-free joint detail. Okay? Another example. Well, we can use these with all pre-decked adjacent elements. For those of you who use the deck bulb tees, here's that particular connection detail right here. And it shares the structural performance of our adjacent box beams in terms of long-term durability and performance. Sometimes we weld that bar across that joint as well. This is an ultra-high performance concrete joint detail in a deck bulb tee that was used out in New York. And you could just see, just from a structural perspective, step back from it. These guys, they're spaced like at 10, 12, 15 feet. Have no structural legitimacy in this connection whatsoever. And that's why you'll see the deck bulb tees, they're limited to low volume roads or roads with low truck traffic. So any of these pre-decked adjacent elements are all viable candidates for this type of connection detail. We have the next beams, we have the modular deck beam elements that's similar to what you see on those Fast 14s. South Carolina is looking at this on all their off-system bridges. The next beams are actually modifying them. They're calling them a next beam 6 and a next beam 8. They pick their shape. They're replacing all of their voided slabs. They like this concept of the prefabricated voided slab bridge, but they don't like the performance. So they stepped back, they sat down with their industry and said, well, what can we do to get that concept into more of our mainstream roads, and not so much our secondary roads. So they modified the next beam, and they went back and they did another study, and they came back and they said, we're going to go ahead and use ultra-high performance concrete. All right? Now we can use, instead of those voided slabs, which create reflective cracking as well, we can use that same prefabricated concept on our main roads instead of our secondaries, and we can kind of keep this uniformity within our inventory. Another example, link slabs. How many folks here from the DOTs are using link slabs, or they're replacing your strip seals with link slabs? Can I get any hands? Maybe one? Okay. All right. Link slabs, and this also applies to span-to-span construction, okay? Link slabs. When I was a state guy, this is our practice with them, this was like 10 years ago. Those strip seals, how long are they lasting for you all? 10, 15 years? Maybe 5? Okay, it was a problem for us. So what we would do is we'd rip out those strip seals and we would place a link slab into that joint. A typical link slab, if you go center line of joint, pretend this girder right here is flipped on the other side over here. Typical link slab is going to be 5 feet on either side of the center line of the joint. A typical link slab is detailed to not crack full, not to produce a crack that's full depth. However, it's kind of 50-50 on whether or not you could get a crack to occur when you design a link slab, and that's why we put a lot of steel in it. And we prevent the cracks from opening up. It's similar to what we do in our negative moment regions. You know, the code says, okay, you got to put 1% of the steel in there, or you can go ahead and try to meet 1.2 MCR. Good luck trying to meet 1.2 MCR. That's a lot of steel. Nobody can do it. That's why we put 1% steel. Well, you can increase your odds from cracking. You certainly will not get cracking in your ultra-high performance concrete if you use a link slab detail. This is one that they use in New York. There's an actual photo of it right there. And again, it's a long-term maintenance serviceability thing that they're doing. It's a proactive, programmatic perspective of removing those link slabs or removing those strip seals and replacing them with link slabs. If you're doing span-to-span construction, simple for dead, continuous for live load, or semi-continuous for live load, that link slab detail applies as well. That would be if you're using just regular old pre-stressed beams. You could do steel, simple spans for dead, continuous for live. That's another example. Let's get out of the superstructure. Let's go down into the substructure. This is a prefabricated column cap with a column. And you can see here, this is actually the ultra-high performance concrete that's making the connection between the two elements. And it's real simple. You can't see it in this photo, but this is a number 9 bar that has a non-contact lap with the number 9s that are protruding from the prefabricated cap. And you look at this and you go, well, we do this with other types of connections as well. You know, splice sleeve couplers, those are very common. But if you look at this strategy and you compare it with strategies like this offers us some advantages. And what are those advantages? Well, when you use a grouted splice sleeve coupler, they're big. I have a photo of this. I don't know if it's in here or not. No, I don't. Okay. They are big. It requires us to take that steel and push it into the element. So we lose a little bit of structural efficiencies with that as well. But what's more important, really, is the criticality of line up, and you can't see it in here. This is the grouted splice sleeve couplers right here, and these are the ports that you push that grout into. Those female receptors are taking these male rebars, and you have to line that all up, and it's critical to do that. You look at this compared to this particular strategy in terms of detailing, and you get more flexibility. Now, if you're doing prefabrication, you still want your things to line up. However, it's a lot easier to not have to worry about these non-contact lap bars in this particular detail, right, than it is right here. Plus, you get to pull those rebar closer to the exterior of the element, and that's what you want from a structural perspective. Okay? One other example, and you kind of have to get more of a global perspective of this. This is actually a 3-span bridge. There's a pier right here, and there's a pier right here. Okay? This is using ultra-high performance concrete and deck connections, prefabricated deck panels. Okay? And basically what you'll see, here's the girder lines that come down, here's the interior deck panels, and those go over 3 to 4 girder lines. And then you'll have a prefabricated deck panel that will actually grab, let's see, we got 2 internal panels and 1 prefabricated deck panel with the parapet or the barrier already cast into place. And we'll do one on the other side right here. This is what New York DOT is doing, and they're doing this systemically as part of their redecking program. They have about 12 of these bridges, maybe a little bit more, that are built. And they're built on their secondary systems, they're built on their interstates. Now, what are the advantages for something like this? Now, this isn't something New York DOT's in-house designers came up with by themselves. They said, look, we like the prefabricated deck panels. However, we need to work with our industry and come up with the deck panels that work for all of us. All of us meaning from the fabricator's perspective, all of us meaning from the contractor's perspective. So they got in a room, they sat down, and they said, what works for us? And they came up with this system. This particular system has no leveling bolts for these deck panels. It has no post-tensioning. There is no overlay. Okay? The beauty of this system right here, it allows the contractors to reconfigure these joints any way they want. As long as they meet the standard details that the New York DOT has sat down and said, this is how these transverse and these longitudinal joints are going to look, you can mix them up any way you please. So this discussion where the contractor sits down with his erector and they're trying to figure out where to fly in these deck panels, they can resolve that on their own. And they're not working with the state DOT to say, oh, well, this work versus this works. You know, all those issues with crane placement and pick weights and things of that nature. So this is sort of the global perspective, and let me show you some actual photos of this right here. Here we go. Okay, so this is the panel that goes over the interior girder lines, and this is the panel right here, and it has the parapet that's prefabricated. This is the approach slab. Everywhere the joint comes up to surface level, that's where the ultra-high performance concrete is going to be. What you're going to see, and I'll show you in the photo next to it, underneath the interior girder lines here, where you don't see the joint, that's a hidden pocket, all right? And it looks something like this, all right? This is where the ultra-high performance concrete's going to go. This is a hidden pocket right here, and this is just conventional grout. Now, they can use ultra-high performance concrete, and I'll show you some advantages, strategies of why you would want to do that. Here's another photo, and this is the panel with the prefabricated parapet attached to it. And that's that ultra-high performance concrete joint right there. Again, no post-tensioning. This is what the underside of the panel looks like that goes over that beam line with the hidden grout pocket. All right? Now, I said you can use conventional grout or you can use ultra-high performance concrete. Now, there's some strategies and advantages and disadvantages of why you may want to do one versus the other. This particular project was actually done when we were dealing with the Buy America issue with the steel fibers, which is a non-issue. We do have a domestic supplier for those. So what they were doing on these particular jobs was they were staying below the Buy American threshold before they kicked in a Buy America waiver request. But still, this is using a conventional grout, and when you use conventional grout or concrete, code's going to require you that your shear studs, the top of those studs, are going to have to be above that bottom mat. If you use ultra-high performance concrete, that rule no longer applies, and we have testing that. So you can keep those studs below. Just plop the panel down. Who cares where the studs are at? All right. Let's see here. This is a picture of the ultra-high performance concrete being installed. And here's a picture of the final deck. And this is what's going to happen over time through wear and tear and UV. These joints will be fading into a different color. And you'll see, if you don't like that, or that seems to be set you off a little bit, don't worry about it. You'll see an evolution of connections. The Canadians are taking these joints and they're making that top smaller. Like I said, we're going to see what I'll call an evolution in connections here. So this slide's kind of fun to watch. If you look at what our connections were like with prefabricated elements in conventional concrete, I just wanted to show you some examples. This is an old hairpin turn, okay? Because, oh, that's easy to do. Well, yeah, it is easy to do, but do note that this deck panel thickness is usually dictated by your ability to bend that rebar. And usually you're throwing in more concrete than you have to because you're trying to meet this requirement. Some actually forego that bar bend requirement and they'll bend it a little bit tighter, okay, just to go ahead and get that weight down. And that's okay to do, but when a guy's bidding that out, he's going to bid out and say, I'm going to probably lose 20 to 30% of those hairpin bars, and so they'll bump that price up accordingly. And that's right to do. Some folks have taken the headed rebar, which is another good detail, to simplify this type of connection detail. And again, it's effective, it does work, but it's costly. And it's costly to fabricate it. So let's walk on over here to go ahead and put some embedments into ultra-high performance concrete. And when I say connection evolution, we're seeing evolution even within ultra-high performance concrete already. So here's actually off of our demonstration Cakes Creek project. This is the transverse joint that goes over the piers, and this is actually the longitudinal joint between the modular deck beam elements. Some people call them PBUs. And again, that's that hairpin detail. This is a job that we just finished about a month ago, maybe less, up in Utah. This is the non-contact straight bar UHPC detail. And you go, oh, that's pretty nice. So we kind of go up here, and you can kind of see how the detailing gets cleaner. This is a bottom form right here. And you can see where people are getting rid of that bottom form, and they're putting a little bottom lip so they can allow for top-down construction. Now, I'll give this one a gold star for now, but it's not a full gold star, to be honest, okay? Because even this joint detail can be improved. Okay? First of all, when I say things like you have to make sure that you prepare that joint in order to get that leak-free detail, you have to have an exposed aggregate finish. Okay? When I said tap down, when you look at this, well, if you have the bottom lip right here and you put the other one, it's going to confine with this. Some people are taking this rebar, they're cutting enough back here, and they'll drop a single mat on top of that, okay, which will create that lap in between these bars if you were to put an adjacent panel there. Does that make sense? Okay, good. All right. So again, these are all just examples. This initiative is not about saying, oh, Ben showed us a bunch of details and we're going to run out here and build this. No. This initiative is more about saying this is the start. We have to throw this out into our industry. Our industry is probably one of the most creative industries out there, I would have to say, because I too am a bridge engineer, and we're going to come up with other applications as well. So let's get out of these examples and let's talk about the deployment strategies, deployment plan, implementation challenges, and things of that nature. So I've bullet itemed some of the implement challenges that we're currently having to deal with. Familiarity with what ultra-high performance concrete is, and of course application. We're seeing just more and more applications, different ways to use the material than we've ever thought before. Recently, we get phone calls all the time, but there's also the familiarity with it as well. The Buy America issue with the steel fibers is now a non-issue. Codification is an item, and we'll talk about that. Of course, cost. But again, the intrinsic goal with this initiative is for the U.S. Is to become a global leader of this technology. We do have resources that are available, but these are more research-orientated type resources, and they're good. I'm not going to go through all of them. I'm going to really show you how to get to them. Just do a web search, FHWA, UHPC. You're going to come to a website like this, and on that website, you'll see this publications right here. When you click on that, you'll see 45 reports. They're going to be broken up in 8 areas: state-of-the-art, program overview, mixed design, connections, materials, eye girders, pie girders, and deck panels. This is hot off the press. When I say hot off the press, a day and just a few hours hot off the press. This particular tech note is specific for this particular initiative. It's the design and construction field cast UHPC connections. And if you all want a copy of this, I can send it to you email as soon as we get done with this presentation. But in here, it's one step closer to sort of that codification and a lot of the field stuff that we deal with ultra-high performance concrete. We have common connection detail examples, some of those that we just saw. There's design guidance, which is important. Design guidance on things like the lap lanes. Specifying UHPC. It's not a specification, but I do have examples of specifications from jobs that we've used in the past, both proprietary and not proprietary. There's construction engineering inspection, but it's not a full-blown out CEI guidebook. Some case studies and deployments, which is just examples of using UHPC. So that's out there. But we do need to talk about the deployment approach. I need feedback from you all. So the things that we do, at least with accelerated bridge construction, which I've been leading for the past 4 years, we're going to follow the same things that we've done in the past. Really, it's 3 things. We do deployment activities, deliverables, projects. They're all focused around national and state goals. Okay? Talk about deployment activities. Take that sheet of paper. I believe it's question number 2. It might be number 3. You can bump into number 2 if you want to. But these are the typical deployment activities we do. Webinars, workshops, conferences, peer exchanges, project showcases. If those are of value to you and to your organization, give me a little checkbox. If there are no value, just give me a little checkbox. Go into question number 3 and just go ahead and hit that. And while you're doing that, I want to propose this for this particular initiative. An online technical assistance service and an online shared project review service. We'll provide a technical website where we house all of our information. We'll provide these 2 services. The technical assistance service is for projects that are under construction. So if there's field questions that are coming up, we'll get some kind of, we'll link it into the website. We'll go ahead and get all our smartphones hooked up, and we'll have a team of folks who can go ahead and answer questions like that. We have the online shared project review service. That would be for projects that are under contract plan development. So if that's something that's appealing to you, look at those little new things and just let me know if that's something of value to you as well. If there's other things that you may need, and I'll talk about some of these other things, but these are the deployment activities, okay? Let's move on to the next category, deliverables. There's 4 things I would like us to do when we finish with this particular initiative. Some of them we're going to be able to start. We might not be able to finish, but we should start them. Some of them we should be able to get done. So I do want a technical website specific for ultra-high performance concrete. We'll do a UHPC project exchange similar to the National ABC project exchange that we already have in place, and we are moving it, by the way. And this will be specific to UHPC. I might combine it with the ABC one. Since it's already in place, we'll just create the keyword UHPC, and you'll get all your projects. Contract plans, bid tats, specifications, photos, 1 or 2 page summary. So we can build off of that architecture as well. The second item, I would like for Federal Highway Administration to develop a core competency module in 5 areas. It is 5, yes. Procurement and specifications. Okay, you have to be able to spec this stuff. You have to be able to procure it. I talked about non-proprietary and proprietary. Design, layout, and detailing. Of the jobs that I've been to, I see things that we as designers can do to help make life easier for the folks out in the field. Materials testing, acceptance, and approval. Our folks in the materials group, they get impacted with ultra-high. And of course, the construction engineering inspection, what I call our CEI group, they have a role out in the field, and of course, construction. When you bring ultra-high performance concrete into your agency, it affects different people within your agency. And this core competency module is designed or is proposed to address folks who have questions in those particular areas. Okay, AASHTO, let's see here. All right, I talked to Carmen about one of these. I needed to talk to you about this, and I apologize. But here it is, okay? So I would like us to propose an AASHTO-adopted UHPC design guide. And again, this would probably take a different time frame in terms of how is it that we're going to go ahead and do this. But again, it's something I think we should be initiating. Other countries do have codes. So you know, I did talk to Mertz, and I did talk to Dr. Kalicki, and I did talk to Wasim, and I kind of threw out some of those design codes that are already out there. So again, I think it's something that we need to kind of vet through. The other one, I did talk to Carmen. This is AASHTO SCOPS T10. This is AASHTO SCOPS T4. I'm part of T4. An AASHTO adopted field installation guide. And again, this design guide, don't freak out, this would be a supplement to our current code. I think this field installation guide, though, it's going to be an overlap of this stuff right here if we do the core competency module. So I'm not quite sure we should be doing this. I think we should go ahead and do this, get it out there on the street, go ahead and initiate this, let it follow a different time path, and see where we go. Okay? So those are the 2 AASHTO adopted materials. And again, I don't think we'll do this field installation guide because we'll have that material here. If this material is good enough, perhaps AASHTO can adopt that. And again, it would be a separate guideline to the current code. And then an NCHRP national fine, basically a domestic scan report, a 20-7. And I did actually talk to Wasim about this, and given that we're collecting all of this information anyway, we might kind of do this a little bit differently than how we've done domestic scans in the past. So those are the 4 proposed, emphasize proposed deployment, deliverables. If you have any comments on that, flip your page over to a repeated question number 3. I was going to reprint this all out for you, but I figured, nah, you'll get it. Just scratch the 3 out and there's a 4. Excuse me, I'm sorry, it's number 5. Those are the proposed deliverables. So there's the technical website and the project exchange. Those 2 go hand in hand. There's the core competency module or core competency manual with the 5 different modules. There's the AASHTO adopted UHPC design guidelines. And then there's the field installation guide and, of course, the domestic scan report. And then there's a spot there for other. If there's something I missed, put it down. Let me know. As you guys are filling this out, I'll show you the feedback that we received from the other summit meetings that we had, as well as the internal division office webinars we had, just for fun. All right. Here's the fun part. This is on the second page. These are, again, proposed. They're draft goals, national and state. I want to put this out for you guys for your consideration. Scribble all over it. The national goals, okay, 100 UHPC PBE projects either designed or built by our sunset date, which is December 2016, January 2017. To stay in line with the accelerated bridge construction theme that we've all been trying to pursue, we'd like to see 25 UHPC PBE projects where the mobility impacts are less than 3 weeks. If that time frame is unreasonable to you, mark it up. Let me know. We'd like to see 25 state DOTs to be fully implemented, and I'll go over the state goals in the next slide. We want to see 50 projects put into the National UHPC Project Exchange. I want to talk about that there. When we did the National ABC Project Exchange, I had Mary Lou reach out to all of you all. This, of course, was a joint collaboration between Federal Highway Administration and AASHTO, and the feedback I got from owners was, if we do this, it does provide value, but it's a whole lot easier to pick up this information for projects that are under development rather than projects that have already been built. It's hard to go back and get all that information, whereas if they're under contract, tell your consultant, tell the designers, you need to go ahead and submit that information. And we'll set up a SharePoint site or some kind of website where we can dump that information. Of course, the other national goals is the deliverables, and as I mentioned, some of them we should get started, some of them we should be able to complete. Okay, so the next slide is state goals, and again, these are proposed. All right, so let's see here. For a state to be fully implemented, we'd like to see a state develop or adopt a UHPC specification. Now, I have examples of UHPC specifications, so you're not starting from scratch, all right? That's easy to do, okay? I put an and or on this particular item right here. To adopt a UHPC design criteria as part of your bridge design manual. Now, that one you should fall out of the chair with. However, that one document I was telling you that just came off the press has design criteria in it. You as an owner can say, okay, we're using UHPC. Here are some things that have come out that has been vetted through research. It's published by Federal Highway Administration. We will adopt this as an interim until perhaps we can get our AASHTO adopted guidelines up to speed. Okay, again, I put an and or an or. So mark it up if you say, oh, that's something we do or we don't want to do. Let's talk about projects. And this is kind of fun, all right? Now, let me back up before I talk about projects. The cost to incentivize UHPC into a project is much less than the cost to incentivize prefabricated bridge elements and systems into a project. When we were incentivizing those projects with PBES technologies, we're putting in anywhere from $500,000 to $1 million plus to get those projects, whether it's an SPMT, a lateral slide, prefabricated column, things of that nature. UHPC, at least for some of the examples that I've shown you, you're looking at somewhere, and again, when I say somewhere, look at these simple span bridges, 2-span bridges, our bread and butter type bridges. You're looking at anywhere from $50,000 to $100,000. Okay? Totally different. Now, we can take advantage of this. Instead of high dollar, low number of incentivized projects, we can have low dollar, high volume type projects, and we can sort of monopolize on that particular fact and do more peer exchanges, more project showcases, and things of that nature. So with that, as part of that, kind of folded in together is the state goal, which is, I gave you guys an option. It says here, 2 projects you get an option to either do an individual or collaboration option. The individual guys would do 2 projects in a 2-year period. Collaboration, that's where a state says to another state, 2 states, or a 3rd state, we'll limit it to 4 per collaboration. They'll say, this state or these 2 states represent us as a group. Collaboration, that's what EDC is all about. So you're doing a project, great. Pick up the phone, we let the other states know when it's occurring. When it goes out to construction, we all go down there, we see what's going on, we'll tag onto it a technical workshop, we'll vet the issues out, we'll vet the successes out as well, and we'll get it all documented, put it onto our technical website as well. So anyway, that's that option right there. 1 project with mobility impacts 3 weeks or less, and again, if that's too aggressive, circle it up. And we want to see 2 projects in the National UHPC Project Exchange. So collecting that data is important. That data serves as our legacies for when we get done with this initiative. It serves as legacies for people who need resources, who are new to our industry, new to UHPC. So it's important we leave those things behind as well. Any questions? Comments? Well, you guys, whew, man, this afternoon crowd is tough. Give you guys a stretch. Come on. There we go. All right.
Ben, I got one.
Yes. Go ahead, Scott.
In the term of project, are you talking project or are you talking bridge? You might
Bridge.
have a project, but 2 or 3 bridges everybody uses.
Bridge. How about that? Guys, come on. We've done these national state goals with accelerated bridge construction. These are the same numbers. Where are we at now? We started off with 100. We're like 1,200. Now, I know people are reporting 2,000, but we're really around 1,200 with the ABC. This is not easy to do. And again, this is where it's sort of like that whose line is it anyway, where the points are added up, but they really don't matter. But they do matter, because every time I get in front of you guys and I go, okay, this is what we're doing with ultra-high, you want to see that national map of who's doing what. And it is important so that we can recognize, okay, we need to go over to this state, or we need to call so-and-so at this DOT to figure out what it is that they're doing. So they're just points. I believe, okay, I only have a couple more slides. I have reached out to our division office to go after this regionalized approach. If you, or if you know of somebody, or if you'd like to elect somebody to help or to become a regional type coordinator, just give me a call. It could be anybody. It could be a consultant, somebody with your staff, somebody you don't like. Anyway, even a university who might be doing particular work as well. Anyway, I've done that with our division office as well. And again, I want to get that regional collaboration so that we have that ability to sort of be in the know of what's going on from that regional perspective. And that's why that state goal has that collaboration option as well. Can I get a raise of hands of folks who know about the monthly ABC webinars that we're doing and are participating? Okay, now we just finished one just last week with an all prefabricated bridge element job, 78 feet in 7 days out in Pennsylvania. Most of you guys know Lou. So that's recording. It's probably going to take another couple weeks to post. On that same FIU website, there's two other UHPC webinars. New York DOT did one. Richard Marcioni did that. That was 2 months ago. And then Dr. Ben Grabiel, the smart Ben, not this Ben, also did another UHPC one on there as well. So there's some good webinars on there. You can just Google search UHPC and you'll find that. That's what that particular bridge project looks like. It was highly successful. I was out there for all of the UHPC. So I'm done with my presentation. I need to recap. So we'll go back to that first question, and I need to ask you guys, now hopefully you know a little bit more about UHPC, okay, strain hardening concrete. So go to number 1, and so how applicable is UHPC for your organization? And just put a little check mark right there. And now it's test time, guys. Real simple. Strain hardening concrete. UHPC is? Excellent. We all get that gold star. Whoops. I botched on that. Sorry, guys. I'm looking at this and I'm not seeing that. Anyway, so you guys did a great job with that. With that, are there any questions, comments, suggestions? I do also want to point out in that questionnaire, there is a spot in there that says, I believe it's incentivizing. It's on this back page. It's the second number 3, project incentive funding, anticipated need. So, you know, that's things like our AID, our STIC, our IBRD, our Highways for Life, all those programs that have incentivized projects. If there's a particular project or program of projects that you guys have in mind, and you think, well, yeah, you know, we do need incentivized funds to help us kind of get off of that stump there, put it down in there. I'll give you an example. I know of a particular DOT who is actually, their local program is actually going after the AID program for their county bridges, and their target goal is to do probably like a dozen, maybe a little bit more, maybe even a whole lot more, to take that chunk of money to do a high volume of very small projects, okay? So I just kind of want to seed you with that example as well. All right? That's all I have. I would sure like to get some feedback from you guys. Any questions, comments? And we can go technical as well. So you know I have Vic Perry in the crowd. Vic, if you go ahead and raise your hand right there. Vic is, he was with Lafarge Corporation for a bazillion years. He tried to retire. We hooked him, and he's helping me out as well. And he can also address any of the technical type questions as well as I. So the floor is yours, guys. And I have to, we are being recorded. I'm sure that went really well. If we're doing questions, we have to go ahead and talk into this microphone. So anything technical, anything about, well, Ben, this plan, we need to talk about that from the state perspective. Most of you all, I have interacted in some form, whether it's webinar, whether it's a workshop, a showcase, or things of that nature. But it doesn't change much. Oh, wait, we got to do this. Hang on. No, you can't. You can't do it. I was told. I don't like it.
With the, I don't think it's working.
You got it?
Okay. With the adjacent box beams, the precast beams, I guess I just wanted a quick recap of that. Did you say that you, in the example you gave, they over-poured the top of those beams before they did the UHPC joints, and then they milled the top of the beams to create the profile that they wanted? Is that correct?
You can profile it down that way, yes. Yeah, that's a strategy on how you can go about doing that. Oh, good Lord, this is goofy. Here we go. Thanks, Carl. I do have a question for you guys. Is this on? There we go. How many folks have differential camber issues with their adjacent box beams? Kind of? Okay. I'm asking states the same question there. If that's a systemic issue in your state, that 2-inch overpour is going to help you. It's going to increase that stiffness. Nice thing about this joint detail that I just showed you, it doesn't care if it's off. When you go back into that profile mode, feather it out, walk away. Oh, wait. Oh, I'm sorry.
You may have mentioned this, but are they eliminating the transverse pulse tensioning in lieu of the UHPC, or doing both to make sure that it doesn't crack?
Excellent question. Yes, they are eliminating the transverse PT, and you can actually eliminate the internal diaphragms that block that box up there too as well. I guess I should stay here. Any other questions? Comments? What about the deployment plan, guys? We're all among friends. Just ignore the camera. I am. I think they're going to edit all this out. Thanks.
Ben and I talked about this, but in Michigan, we're having issues with, we like the idea of the UHPC in its applications, but we get some pushback from contractors that they're kind of hesitant to use it due to the cost and some of the constructability issues. So they immediately want to go to the cast in place option and possibly just throw more crew at that in lieu of doing a UHPC. I was just curious if anybody else has had that same struggle.
Guys, you know, I see it everywhere. You know what My answer is crank down on the time. But, I mean, that's, you know, I know it's not that simple because you have to deal with your community there. But let me share with you the feedback I got from the contractors who did that Pennsylvania job and the contractor who just finished that deck panel job in Utah. It's the first time that they used ultra-high performance concrete, okay? The one in Pennsylvania is what I call a small to medium small contractor, okay? And that was the first time they used that product. And you watch the crews. In terms of learning curve, it's about an hour. Feedback after. Guys, is this the right thing to do? I mean, honestly, tell us. Don't tell me because I'm the Fed. Tell me, you know, is this what you guys want to see? It took them 3 hours to put those modular deck beam elements down there. It took them a half a day, and it took them a day to go ahead and form underneath. And that's where they'll come there and say, if you can do that bottom lip and eliminate all that, it'll save a ton of time. In terms of working with the material, again, you watch them. It's like about an hour. They get it, and they're moving, and it's a non-issue from that perspective. The deck panel job that we did in Utah, now this contractor's done about 30 deck panel jobs with the longitudinal post-tensioning, and I asked them the question, I said, in terms of using the UHPC type of deal with no PT versus our conventionally post-tension decks, what's it like? From the risk perspective and from the ABC perspective. He's an ABC contractor, okay? And he said from the risk perspective, it's actually less when you're dealing with, when you look at it from a contractor's perspective and the things that could go wrong with doing your PT versus just mixing up the grout and dropping it into the form. As far as the formings go, and you hear people say, oh, they got to be watertight, they're going to leak out. Yes, that's true, but guess what? The deck panel jobs, they're all watertight too. Even your conventional cast-in-place deck, we caulk all that up anyway. So that forming really doesn't change much. He did say this, in terms of speed, this was interesting. And again, he had that open bottom, so he had to form up underneath. He says it's a little bit slower. It's kind of hard to tell, but it's a little bit slower because they had to do a lot of forming up underneath. And they were worried that they were going to have their forms blow out. Not because of leakage, they thought this thing weighed more. And they were really aggressive with the forming that they did. And there were some forming things in terms of layout that could have been simplified from a designer's perspective. I mean, really, if you think about it, when you're doing an ultra-high performance job and you're laying out your joints, 90 degrees all the way. If you see a skew, there ought to be a really good reason why you're doing a skew, all right? Because the guys out in the field, they have to button all that up, okay? So from that ABC perspective, but it's not much slower. Flip back to the Pennsylvania job. When we're watching that UHPC go in there, and the guys are like, my gosh, it clings to everything. And that contractor says, in terms of cost and speed, you could see you're paying for quality. That is a high quality product. Just watching it in its fluid motion, it's clinging to the rebars, and that's what the guys were saying. It's like JB Weld with steel fibers in it when you mix it, but in terms of workability and things like that. But anyway, that's sort of that feedback there. But again, with your question with the cost and things like that, you know, we're up in New York and they're doing all the deck panels like that. And honestly, with all those shear studs that you saw in that photo, that's because of that fatigue issue that everybody's kind of dealing with, AASHTO. That's following the AASHTO code right there. I know if I was an owner, I'd say I'm not following the AASHTO code on fatigue if I'm putting that much shear studs on there. I'm raising the neutral axis. But still, they did it. I asked the surveyor. I said, my gosh, I mean, if anyone who's feeling the pain, it's got to be the surveyor, right? He goes, we got it. We got it figured out. The prefab deck panel concept, in terms of doing the cast in place, and they're knocking those jobs. That was a weekend job, wasn't it? 2 bridges, 1 weekend? And they were roughly about, we're going to say about 200 feet each, 280, something like that. So you can't beat it in terms of time. So they're really happy with that. So, oh, yeah, sorry, I forgot.
Are you seeing new decks or redecks mostly?
Yeah, good question. I'm seeing more redecks, to be honest. New decks, no. You know what's interesting, though? We're doing a network-tied arch. You know how you throw the tension back into the deck? We have to use a prefabricated deck panel. And guys are like, oh, it's because you're the prefab guy and the ABC guy. I said, no. Load up that arch with all that dead load, put those deck panels down. So you saw us do it when we did the Lake Champlain Bridge, right? I don't know if we ended up doing it with the bridge, the land between the lakes in Kentucky or not. I think we did. I'm pretty sure we did. You'll see them in cable stay bridges. Makes a lot of sense there. We'll just go ahead and put the deck panel down. So I'm trying to think if I've seen a lot of new bridges with deck panels, like the full width. Just in my travels, not a lot. I don't know why, you know. I will say this, I do have some owners who've come back and they said, you know, Ben, and I can give you an example of a project as well. We're looking at the deck panels again because of the deck panels that we have in service. They're performing better than our cast-in-place decks that were built in the same era, the old deck panels. And of course, if you think about it, you go, well, step back, why? The post-tensioning, it's confining everything. You can create a zero-tension deck, things of that nature. So you could see there was an owner that said, is there a way that we can actually standardize the deck panels, similar to like New York, such that here's our deck panel standard. You want to do it cast-in-place or precast? We don't care. I have contractors that actually are calling me up and saying, the state's not allowing us to do deck panels. Can you give them a call? There's a lot of sense from the contracting perspective for some contractors to actually do the deck panels. Of all the places, there's a job in West Virginia in the southern part, and a contractor called me up and said, you know, we need to get this one pushed through. And it was like, it's so remote, and it's a big job. I think this is a 1,200-foot long job, bridge. And it was like, where are you going to build your panels? Oh, they're coming from Pennsylvania. We're going to drop them in. But there was a business sense. There's a business component from their perspective. It allows them to take their workforce and actually build the panels and then go ahead and ship them down. So they can do some things there. So you hear different things. I have other contractors that are going after the design build projects. In fact, we had one just a few weeks ago who was in two different states, and he was proposing ultra-high performance with deck panels on, both of them were rehabs. Both of them were rehabs. And just saying to the state, we could do it this way, or if you want, you could do it this way. So from the contractor's perspective, we're seeing, and these are contractors that are a little bit more on board with the whole ABC concept. I'll say this, the contractors that are on board with the ABC, even the smaller ones, this is one in the Northeast Quarter, very small contractor. When I say very small, they love it because it allows them to get the job off of their books. To be able to get done with a $1 or $2 million job at the beginning of the year for a small contractor allows them to move forward onto the next job. So it makes a lot of sense from them. What's interesting, and I'll share this with you guys, if you're talking about accelerated bridge, for a contractor like that, in that environment that they work in, he said what would actually help, this is a little simple span bridge that they did in like 2 weeks. He says we could have done this in a week easily. But it's the ability to have workers that can come in, and we don't hire and fire. That's not the environment in our particular state. We hire and retain. However, if we had 2 of these jobs that were ABC, we'll just go ahead and take a crew, we'll shift them back and forth. So the ability to actually stack for those smaller contractors, and they'll say, and that we'll do, we'll pick up 3 or 4 more people, and then we'll actually have that ability to, some of them are self-performing, and then we'll go ahead and they'll just do the ABC component with that double crew. So there's some strategies. You need to talk to your contractors about that and really say, as an owner, you know, if you like it, if it's providing the service that you all like to see to your customers, the public, have that frank discussion with them and say, well, you know, we all around the U.S., in these past 4 years, you know, all this accelerated bridge construction is coming out. You know, we're not seeing, oh, this is the bad, or this is the wrong thing to do. And I can tell you this, before I started this, and when I inherited it from Claude and Lou, I was told, Ben, your contracting community is going to be your biggest hurdle. And I can tell you this, the contracting community has probably been one of my biggest, I'll say, partners in crime on some of these jobs that we do. Questions? Oh.
In the New York example, cost savings, I know there's a time savings with the precast, but cost savings compared to a regular deck pour? And the other question is, when they set those precast on the beams, how are they grouting the underside? Do they have inserts?
So the question is first on cost savings. Compared to a conventional, I cannot answer that. But what I can answer is this. The governor came in and decreed that New York DOT will have an accelerated bridge program 2 or 3 years ago. It was so successful, and they threw a bunch of money into it. I think it was something like, I want to say 3 to 4 billion, maybe 2. I might be off on that, but somewhere between the $2 and $4 billion range. They ran it for 2 years. So successful, governor came back and said, you're going to do it again, and we're going to fund it again. So this little money issue, you got to think about this in the bigger context, you know, and who it is that you're servicing. In terms of cost on that particular job in New York, they did 2 bridges in a weekend. And there's project savings that you can do within those projects. MOT is only, it's limited. And you get 2 bridges for the price of 1 MOT. Not a bad deal. So this little premium that you're paying here, it's going to transfer, you're going to see savings within that project. And I always employ people, you cannot look at just the bridge cost. Do not do that to me. Being a former project manager myself, who's done high volume projects, you need to look at the total project cost. I'll give you an example in the planning side. So I'm working with states who are looking at accelerated bridge construction from a programmatic perspective, all right? And that's where we pull in all your section heads. Let's get all the environmental people, the utility people. Let's get the folks in the MOT and traffic, things of that nature. And we want to talk to you guys about accelerated bridge construction. The question that goes out to the environmental people, I always ask this question. When you're going through the environmental process with an ABC job versus a conventional job, is it better, worse, or the same? I have one state, and it takes time to migrate into this mode. It does. I get it. You know, we all operate in a big ship, that little itty-bitty oar, and being able to steer that is very difficult to do. I've asked the folks that do the historic side of things, the NEPA side, the 404 side, you name it, the whole gamut. 40%, 30 to 40% reduction on that side translates into things that you can do onto your bridge side. And if you're an owner and you're trying to run a program, and you're running these projects through the gauntlet, and you're getting hiccups like this, we've done all these peer exchanges. We did 5 peer exchanges when we ran an EDC 1 and 2. And I asked the group, how much do you spend in-house with utilities and right-of-ways versus what you spend out-house? And what's the question? What's the response to that? Utilities. We're spending probably $5 internally for every dollar that we spend externally. When you're dealing with right-of-way, easily double that number, probably triple the, quadruple that. So when you're going after ABC, and you're looking at it that whole project perspective, in terms of cost, in terms of time, not just on the bridge, but on that whole project or your whole program, you need to really think about it from that context. You asked about how it is that they grout that. So they actually use leveling blocks on that. If you saw the haunches, they actually used metal haunches. This is really cool. They actually took and spot welded those the metal angles onto the sides of that. So the guy just set up the gun to get the heat right, put the angle up there. You already have the elevation marks that are already set by the surveyor that already ran through there. That's it, ready to go. Then you put the leveling blocks in there to hold the 4 corners of that. And it's got little shims that you can put in there. That's what they like to do. There's a bazillion ways to skin that cat. The reason why they don't like the leveling bolts, because what happens when we pull up a prefabricated deck panel, we measure underneath, we preset those leveling bolts before we fly it in over the girders. If we have to adjust it, you can't just crank on that leveling bolt. You'll follow the threads. You have to lift it back up, and the guy has to, make an adjustment. So it's a time thing. However, you get that surveyor out there in front of the crew, and they can go ahead and do it in other methods. So it's pretty interesting. Honestly, I thought this guy was going to rip my head off when I asked him, so how's it going? He's like, this is not bad. You just have to, you set up your spreadsheet and you get in front of the crews. And to be honest, it's, he says, actually, we all know this. Every time we redo a redeck, you don't know how the bridge is going to spring back. Some spring up high, some spring low, some spring like this. You never know. This actually provides them more flexibilities to address those types of things. So, yeah, it's pretty neat. So anyway, I'm just, I'm throwing things out there, guys. But any other questions? Any other comments? I know it's late. Provide me your input there. Oh, I needed to show this to you. Hang on a second, just for fun. Here we go. I got some backup slides in here. But watch this. This is always fun. Here we go. So I had to do division office webinars internally, ask that same question. This is what our division office guys thinks of you all. So just for fun, all right? Whoops, I went the wrong way. Here we go. Okay, so the green was before and the purple or blue was after. And I hit about 30 to 50 division offices in our internal webinars. And they got this sort of the same thing as this, more of the deployment stuff, to be honest. So you could say, you got 7 on the very high, you got about 12 in the high, and then what you do is you take your medium and you kind of split it. Some will go this way, some will go that way. That's fine. Okay, so watch this. And well, this is even funnier. You look at the guys that say low to very low, I think I validated from them that they really don't want it. So that's okay, we can have a little fun with that. But here, if you take this and you flipped it or mirrored it, summits to date, we've hit about 15 owners, 12 in the state, 3 in the local agency. This was the before, and this was our after. So we can kind of see like 7 and 10, we're in a good spot. And then we look at our 3, and that can go backwards and forwards. So what I'm going to do is we run around and do all these summit meetings. I'll do a closeout type webinar for you guys and kind of give you the feedback that we receive collectively from a national perspective, and then kind of give you sort of, okay, this is what we're going to do, guys, and this is how we're going to go about doing it. So hopefully around January, maybe February, we can actually roll that out. So I just wanted to share that with you all. This is a question actually that came in. One of the state guys had asked, well, if we're going to do the adjacent box beams, we don't want to do this lap joint to where that rebar is over the center line because the guys don't want to blow the holes in their formwork. So it's no problem. Keep that lap inside. You can go ahead and create something on your actual form, drop it in, and this is where you actually drop that lap bar on top of these blue bars, and of course this green would be a little bit longer. Just drop a bar in there, simple as that. Top-down construction. Better than, I think that's all the slides you got there. Better than something like this. Or this. All right. Guys, thank you so much for your time. Feel free to reach out to me. Most of you all have my contact information, benjamin.bierman@dot.gov. And just leave your stuff on the table, and I'll go ahead and pick that up. All right? Have a great evening, and enjoy the rest of your EDC conference.